Hi there, my name's Matthew Wolford. I'm a data scientist, a business psychologist and researcher, and I have experience in social market research, academia and regulatory authorities. Now, what many people may not realize is that psychology is actually a quantitative discipline, and with heavy emphasis on research and statistics. And funny enough, these statistics are also used in machine learning. And so there's a lot of crossover, in my opinion, between what on the surface actually appear to be two very different worlds. So fast forward to today, and I have taught research and statistics units at university. I've used data and statistics for creating client insights, and I've recently completed General Assembly's Data Science Immersive course. So I think it's pretty safe to say that I have a passion for data and how we can use it for insights, decision making, and automation. So in this brief video, I'd like to share some of my learnings and experiences as part of completing my Capstone project at General Assembly's course. And this project really drew upon my background in psychology, in addition to my learnings in machine learning to detect deceptive statements in human beings. So the problem I was trying to solve was, can we accurately detect deception, given that research shows that humans are pretty poor predictors at detecting deception, with accuracy only around the 54% mark. And this holds across a whole range of populations, including judges, law enforcement personnel, recruiters, and students. And detecting deception is important for pretty obvious reasons, such as detecting criminal behaviour or assessing whether or not a witness is being deceptive. But it's also important to look at the flip side of this, in that we need to detect when people are also being truthful. And this is, for example, this is important really because around 10,000 people in the US are estimated to be wrongfully convicted each year. An estimated 4.1% of death row inmates are estimated also to be innocent. We also have to consider police enforcement officers who may engage in perjury. And we also can consider this from a financial impact in terms of, for example, the largest payout for a wrongful conviction being 1.5 million. So detecting truth is also just as vital as detecting deception. So one of the key real issues in accurate deception is understanding cues around deception. And I've just put some here of things that have and haven't been actually found by research to be related to deception. However, some people or a lot of people may actually think that some of these are actually indicators of deception. So when we look at some of these cues, we can start to see that actually they cover a broad range of domains. And these include our vocal, verbal, and lexical features. So we need to really sort of try to understand or have an approach that can encompass all of those, that vocal, that behavioural, those lexical features. Some of the current approaches, so we have deceptives training. One of the issues with this deception training is that research shows it only increases on average accuracy by 4%, which is pretty low considering the high costs of the courses. We also have another common approach, which is the polygraph test, yet most scientific bodies and associations have concluded that these are pretty inaccurate and may not be valid for purpose. So I proposed a solution where I'd seek to integrate psychological theory and research findings with machine learning to see if we could improve the accuracy of deception and truthful statements. So I tested and validated a number of independent models covering each of the feature domains known to be related to deception. So gestures, vocal, sentiment, parts of speech, and a bag of words models was in there. Within each of these domains, I selected the best performing model from a range of models I used. And these covered logistic regression, k-nearest neighbors, random forests and SVCs, and then I used the predictors from each of those individual models as features in a second stage of modeling, or a second step model. So this was the fusion model, and then by using this particular model, ended up having an accuracy of 88% on a holdout set, which is quite clearly a significant improvement over the 54% accuracy of humans in general. So what are the benefits of the approach? Obviously, potentially another tool to help with detecting truthful and deceptive statements. This approach can help us reduce our reliance on expensive and unreliable polygraph equipment. It can help us overcome our human biases around deception and truth-telling, and help improve outcomes where the detection of deception is pretty important. And obviously, we show an increased accuracy over current approaches as well. So I hope you found this interesting and learned some things like I have done along the way. My project can be found on my GitHub pages, and that location or that URL is there to follow up. So please visit there to learn some more. And my contact details are also shown here. I'd love to hear from anyone who'd like to learn more about this project or anything else data science and psychology related. So after that, just remains for me to say thank you. Look forward to hearing you, and I hope you enjoyed this. Thank you very much.